Welcome to solverfy.
Hello students, let's solve this problem. So the concept of free body diagram and force resolution, static, friction, condition is used to solve this problem. So initially we can find the relationship for magnitude of the resultant of the two equally hard rock by using the expression for the magnitude of resultant vector from the vector triangle law and consider it as the equation. Now let's calculate the angle, that is theta, by using the expression of friction angle. For the case when the mass begins to slide, we can calculate the resultant of the two equal hard drop, that is F1, and apply the static force equilibrium condition along the vertical and horizontal direction. First, on calculating the minimum tension by rope to move the sled by using the equation for vector V, making an angle theta with the positive x-axis, and then the components is N, and the horizontal component is Vx, and the vertical component is Vy. That is, Vx is equal to V cos theta and Vy is equal to V sin theta. Here, R can be written as root of P square plus Q square plus 2PQ cos phi. Here, P and Q are the magnitude of the vector and R is the resultant vector. So here, and phi is the angle between the two vectors. And the weight of the body, W, is equal to m into g, where W is the weight of the body, m is the mass, and g is the acceleration due to gravity. And the expression for static friction is written as Fs equal to mu s into n, where Fs is a static friction, mu s is a static coefficient of friction, and n is a normal reaction. And the expression for kinetic friction, that is Fk, is equal to mu k into n, where Fk is a kinetic friction, mu k is a kinetic coefficient of friction, and n is a normal reaction. So the static force equilibrium condition in the horizontal direction is given as summation of Fx equal to 0 and summation of Fy equal to 0. Here summation Fx and summation Fy are the sum of all forces acting along the x and y directions. Now the sign convention for force are the forces acting in the upward direction are taken as positive and the forces acting in the downward direction are taken as negative. So the forces acting in the rightward direction is taken as positive and that of the force acting in the leftward direction is taken as negative. So since both ropes are equally hard, the tension in the ropes will be same. That is, T1 is equal to T2 is equal to T, and T is a tension along either rope. So writing the expression for the magnitude of resultant tension, we can write F1 is equal to root of T1 square plus T2 square plus 2T1 square T2 square into cos phi, where F1 is the magnitude of resultant tension in the rope and phi is the angle between the two ropes. Hence, on solving, we can write here phi value is equal to 25 degree. Further, we'll get the value for F1 as 1.953 T. Now let's calculate the value of angle, that is theta. For that, theta is equal to tan inverse of mu s, where mu s is the static coefficient of friction. Therefore, theta value is equal to tan inverse of 0.619. Hence, we'll get theta as 31.76 degree. Now, in order to calculate the resultant of the tension among the two sides of the rope, the angle, that is phi, is equal to 25 degree. It is given in the question. Now we can write by looking in the front view, that is x bar, the weight W is equal to mg and the vertical component is F1 sin theta and the horizontal component is F1 cos theta. So here the static force equilibrium is along the horizontal direction. Therefore, summation of Fh is equal to 0. That is, F1 cos theta is equal to mu k into n. And substituting the values for theta, that is, theta is equal to 0.405. We can write F1 into cos of 31.76 degree is equal to 0.405 into n. We'll get n is equal to 2.10 F1. Now, summation of Fh is equal to 0, hence we can write F1 sin theta plus n is equal to mg. So, on solving and substituting, we can write F1 into sine of theta is 31.76 degree plus 2.10 into F1 is equal to 261 kilogram into g. On solving, we'll get the value for F1 as 974.89 Newton. Now let's find out the tension. 974.89 Newton is equal to 1.953 T. Therefore, T will be equal to 974.89 divided by 1.953. Therefore, tension T is equal to 499.17 Newton. Hope you find this video useful. Thank you.